This is a 2014 free response questions 1, and I'm going to look particularly in this video at questions 1 and 3. I'm not going to work on question number 2 because I'm preparing this for the year 2020 AP test, and area volume is not tested, so I'm not going to use the time right now to review question number 2, but focus on question number 1 and 3. Question number 1 is a calculator question, and question number 3 is not a calculator question. So let's take a look at the prompt in number 1. In number 1, we see that grass clippings are placed in a bin where they decompose. For the time interval 0 to 30, the amount of grass clippings remaining in the bin is modeled by A of t equal to this exponential function. So A of t is the amount of grass clippings. So it's important for me to remember that A of t is the amount function. A of t is measured in pounds and t is measured in days. In letter A, we are finding the average rate of change. That's pretty straightforward, of A of t. And we know that average rate of change is simply y2 minus y1 over x2 minus x1. So when we look down at the work, we see that's extremely easy. We're going to use our calculator. I would put the function a into y number 1. And then we're going to have a of 30, whatever that number is off the calculator, minus a of 0, over 30 minus 0, and I want to be sure to see the difference quotient, and then I want the number reported, and I'll accept negative 0.197 or negative 0.196 because you can round or truncate your answers, and to get that 1 point you also must have units, which in this case is pounds per day. Notice that A was the amount of pounds of grass clippings, and then the denominator is time measured in days, so we get pounds per days for our unit. In letter B, they're moving on from the average rate of change. Now we're talking about, let me clear some of this up a little bit, clear the annotations. In letter B, we are now moving from average rate of change to instant rate of change, and this is a calculator problem, so that's extremely easy. We're going to do that with our calculator, but what's important is interpreting the meaning of the value in the context of the problem. So let's first come down here and take a look. As I said before, you would have had y1 equal to the function a of t, so you would use your calculator to find the derivative at 15. I think it's important to at least write down what you're doing, and then you can report the value rounded or truncated, so you get 1 point for finding a prime of 15. Now the interpretation is really important. A prime modifies A, and A was the amount or pounds of grass clippings. So when we write this interpretation, we're going to describe something about the amount of grass clippings, whether the amount of grass clippings are increasing or decreasing. Notice that the derivative is negative, so we're going to talk about the amount of grass clippings, and you can see it here. The amount of, on day 15, the amount of grass clippings in the bin is decreasing at a rate of whatever number you reported, pounds per day at time 15 days, or you could have the at 15 days in the beginning. And again, that number comes straight off of your calculator. In question C, I'm going to clear the board again. In question C, we are looking for a particular time at which the amount of grass clippings, and remember A of t was the amount of grass clippings in the bin, is equal to the average amount, or the average, in my class, we always say the average value of the amount of grass clippings from 1 to 30. So average value, 1 over 30, 0 to 30, so b minus a of t dt. So we're going to use the calculator to produce this number right here, and then we're going to figure out with our calculator where a of t is equal to that number. So if you come down here and look at the work, you can see that the first thing we're looking for is that the student understands that we're launching into the average value. So we need to see that integral set up. Now we don't necessarily need to see that number, or well, we do need to see that number, but we don't have to see the answer. You would likely be showing a lot more work than you see right here. So on your paper, you would have found 1 over 30, 0 to 30, a of t. You would have found that number. So assuming that a of t is in Y1 of your calculator, you would use the calculator on the home screen to determine the average value. In other words, you would get an answer for the average value and then store that value in alpha A. And then remember they said when is the amount of grass clippings, so we're going to let y number 2 equal to alpha A, whatever number you stored in there, and we're going to figure out when does A of t equal to that average amount that you stored in alpha A. So we're going to graph with our window open to 30, because that is our interval from 0 to 30, and we're going to find the point of intersection between y1, which is a of t, and y2, which is the average value that you found using your calculator, and you'll find that occurs at 12.415 or 12.414 days. Do not round that number to 12 days unless they tell you in the prompt to round to the nearest whole number. In letter D, let's clear the board again and see what we're doing here. Okay, clear the annotations. In letter D, for t is greater than 30, so now we're going to go outside to that 30-day window. L of t is a linear, notice the root word, linear approximation to a at t equal to 30. So they're telling us very clearly we want the equation of a line at t, or you would probably think of that as x equal to 30. It's a better model for the amount of grass clippings after 30 days. Use the equation of the line that you write to predict the time when there will be 0.5 pounds of grass. That's a y value. Show the work that leads to your answer. So the key word, as I said, is linear. The root word of linear is line. We're going to start by writing the equation of a line. The equation of the line at x or t, however, whatever variable, that really doesn't matter what you use here. And then we're going to find a of 30 on our calculator, because remember we already have the a function. And then we're going to find a prime on our calculator, because that's going to give us the slope. So this is going to be our x number 1, this is going to be our y number 1, and then we're going to use the calculator to get the slope. Then we're going to write the equation of the line, get y by itself, and then we're going to substitute 0.5 for y, and we're going to solve to find out when that occurs. All right, so let's look at the work down here. You can see the College Board work is a little fancier and could be confusing for you. So over here, well, I would start with y minus y1 is equal to m times x minus x1. And on the calculator, remember what I said is we would find a of 30, and we would store that number in our calculator, but we can write it as, well, in this case it would be plus, oh, that's a prime, I'm sorry. Let me erase that. So a of 30, I wasn't reading very carefully, is 0.7829. We're going to store that long decimal value, but over here on our paper we're going to write 0.783 is equal to the m value that we found off the calculator, which is negative 0.556 times x, and you can do t or x, minus 30. Then I'm going to add the 7.83 to the right side. Now again, I'm using 3 decimal places in my work, but on the calculator now I'm going to put the equation of this line into y number. It doesn't really matter what y I put it in, but I'm putting mine in y4. I'm putting in 0.5 in y3. I'm going to turn off y1 and y2, and I'm going to find the intersection of this line. Now it's going to be greater than 30, so you're going to have to open your window greater than 30 to find the point of intersection. And when you do, you'll see that the point of intersection is 35.054. Okay, let's move on to question number 3. Oh, this is just some student work to show you how a student actually wrote up Part D and got full credit on this. So you can see that the student said that L of t is the tangent line, which is what I talked about. They calculated A of 30. Notice they rounded it off to 3 decimal places. They rounded it off to 3 decimal places, but in their work they're going to store that. They said that this is going to be the slope of their line. Here's point slope form of the equation, just like we talked about. They're substituting the values and then setting that equal to 5. I don't know if I can drag, yeah, there it is. They substituted 0.5 in place of y. I mean, this is not how I would write my work up, but this is how the student wrote their work up, and it's actually the same thing. Question number 2, I said I would not be going over in this video, but we will take a look at question number 3. Okay, so in question number 3, this is our geometry question, and really make sure you get all the points out of this question. It's not a hard question, so let's take a look at it. In question number 3, the function f is defined on the closed interval from -4 to 5. The graph of f consists of 3 line segments and is shown in the figure above, or in our case, in the video, it's the figure to the right. So there's line segment 1, line segment 2, and line segment 3. Let g be the function defined by g of x is the accumulated net area from -3 of x of f of t dt. So some things I want you to pay attention to. Notice that all of the area accumulations, if we have to accumulate some area, will begin at -3 as defined if we need some g values as defined by this integral right here. So be careful. It's very tempting to always try to start your area accumulations at 0. The other thing that I want you to pay very close attention to is the fact that g is a definite integral. So g is a definite integral right here. And so the derivative of g is the derivative of a definite integral, which is the FTC part 2. So g prime of x is take out the t, put in the new function, and multiply by the derivative of the new function. Critical that you understand that g prime of x is f of x, and you'll notice that in my work down here, as soon as I figure that out, I write down on my paper or make a note that f is g prime. So letter A, the first thing that they want us to do is find g of 3. So we're going to accumulate the area, again beginning at -3, stopping at 3, and you have to find the area of the triangles geometrically. So we're starting at -3, and we're stopping at 3, which is here. Now be very careful. The temptation is to stop at 4. Stop at 4, because that's the natural stopping point of the graph. So I'm going to accumulate this area from in here, here, and here. But notice, let me clear those annotations off. Notice that we don't really know, so when we calculate the area of this triangle, we know that's 1, but this distance right here, now most students would probably assume that it's -2, and it actually is -2. But we really need to make sure that it's -2, and in order to do that, what we need to do is clear the board again. We really need to write the equation of this line to be sure. So the equation of that line, the y-intercept is up here at -4. We have a drop of 8 and a run of 4, so rise over run. So the slope of that line is -2, and the y-intercept is 4. So then I can substitute 3 into the equation of that line to confirm that that y value is -2. Now there's no points in this problem to make sure that the student actually writes the equation of the line, actually calculates. If the student makes an assumption and is correct, that the y value is -2 and correctly calculates that area, they're going to get that credit. But you just kind of need to be careful. So when we accumulate, as I said before, we're going to take the area of 6, which is positive. We're going to add 4, which is 10, and we're going to subtract 1 because the area below the x-axis, in this case, because we're moving from left to right, is is negative, and so we get a net area of 9 units. Moving on to letter B. In letter B, we are looking for the open intervals from -5, so I'm going to block that off, 1, 2, 3, 4, 5, so we're starting here from -5 to 4, and we're stopping here where the original function g is increasing. So if g is increasing, g prime or f is positive. So we can see that this graph is positive in the yellow zone, positive, 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 okay? And then the second thing that we want to know is, at the same time, when is G original concave down? So G original is concave down where G prime, first derivative, or F decreases. So the decreasing interval, that's a decreasing interval of this graph, and this is a decreasing interval of this graph. So our regions of purple and gold, so purple and gold, go Pirates, are from, or is from -5 to -3, and from 0 to 3. And if we look down at the scoring guide, oh wait, 0 to 2, sorry. There it is right there. So the graph of G is concave down, increasing and concave down here, and you can use interval notation. You don't have to use inequality, so you could have -5 to -3, and you could have 0 to 2, and that's that connection point again. G prime or F, they have it here, so they don't have to keep restating it, but you can, is positive and decreasing on those intervals. Moving on to letter C. Let me clear the board again. In letter C, we're looking at a brand new function whose name is h of x, and h of x is comprised of another function, g of x over 5x, and we want to find the derivative of h. So what we're seeing here is a quotient which requires a quotient rule, down d up minus up d down over down down. So the quotient rule, here's the down, d up minus up, d down over down down. Be careful because the temptation when you do over the denominator squared, it would be very tempting to write 5x squared. And once you write that 5x squared, you've already lost the answer point. You might get one of the 2 points on the derivative, but so be careful. Use parentheses. Anytime you're going to square something, use parentheses. Please, please, please let me encourage you. I would have left my answer as, I would like for you to leave your answer as 5 times 3, and don't use dots. Use parentheses. This is very sloppy. Let me make that a little bit neater for you. So that would be 5 times 3 times -2 minus 5 times 9 over 25 times 3 squared. I would love and prefer you to leave your answer that way so that you don't end up making any arithmetic errors that cost you the answer point. So do not, on the AP test, do not simplify your answer. And then lastly, letter D. In letter D, we are looking at a new function whose name is P. And P has an outside function of f and an inside function of x squared minus x, and we need to find the slope of the tangent line. Slope of the tangent line is derivative of P, so we're going to need the chain rule because we have an inside and an outside function, and we're doing that at x equal to -1. So the derivative of the outside is f prime, leave the inside alone, and the derivative of the inside is 2x minus 1. There's your chain rule. Then you're going to substitute, I think it was 1 or negative 1. You're going to substitute negative 1. Be very careful and get those values, and you can leave your answer. I mean, I know it sounds silly, but you can leave your answer as negative 2 times 3, or negative 2 times negative 3, because on a stressful AP test, you could actually multiply that and get negative 6 and lose the points, so do not simplify your work. So hopefully you'll come back and take a look at questions 4 through 6 from the 2014 to support your learning.